Okay, hi guys. So I'm going to do a video for lesson 4.2. Hopefully you can see it on my screen here. And what I did is I uploaded this lesson twice into the class notebook. And one is labeled blank, so you have a blank copy there if you want it. And then this one is labeled something like completed notes from video or something. I can't remember exactly what I labeled it, but it's the one that's going to be completed as I go through this video. So if you wanted to pull up the blank one or print it or whatever, you have that also. Okay, so we're looking at lesson 4.2. I've moved ahead here to the actual start of the lesson, and this is called Comparing Change, and it deals with personal finance and citizenship. So it's very related to what we did last lesson with the latte and the cell phone plans, where we made linear models. So we're going to be doing the same thing here. We're going to be looking a little bit more at that rate of change or slope when we do this. But it's very much related to what we did in lesson 4.1. Okay, so it says in this lesson, we will build linear models to estimate soda and milk consumption over time. While our models will not be perfectly accurate for each year, they will provide rough estimates that allow us to see how soda and milk consumption have changed over time. Over the last 60 years, consumption per person, so consumption just means how much is consumed, how much is used, or in this case, how much milk and soft drinks people drink. Consumption per person of milk and soft drinks has changed drastically in the US. In 1950, each person in the US consumed an average of 36.4 gallons of milk during the year. In 2000, that number had decreased to 22.6 gallons of milk per person. Meanwhile, the average number of gallons of soft drinks consumed per person in 1950 was 10.8. By 2000, this number increased to 49.3 gallons of soft drinks per person. Okay, so we are going to want to kind of remember this paragraph right here, because all that information about how many gallons of milk and soft drinks in each of the 2 years, we're going to use that to build our model in a little bit. So we'll just kind of put these brackets around it so we can find it easily afterwards. In the following questions, you will find out when the consumption per person of milk equaled or will equal the consumption per person of soft drinks. So in other words, we're looking for, we can see that the amount of milk consumed went down and the amount of soft drinks consumed has gone up quite a bit. So when were those equal? When did the amount of milk people drank, an average person drank during the year, equal the amount of soft drinks they drank in that year? For this problem, we will build linear models for milk and soft drink consumption. Assume that the change in consumption is linear. So remember, linear, those are the graphs that make a straight line. Straight, it can be slanted like this, but not a curve, right? So it could be like this, or it could be like this, or it could be like this. But we talked about how if the change is linear, it means it has a constant rate of change. For example, for the latte, for every latte that was bought, the amount on the card went down $2.63, right? That was a constant change. Okay, so let's take a look here. So here we talk a little bit about the slope. We talked about the slope is the rise over the run, or the vertical change of a line divided by the horizontal change of a line. So again, if we have a line that does this, our slope tells us how we go from one point to the next, okay? So rise over run. So from here, we're saying, how far up do I have to go to get to my point? So I'm looking at just straight line, straight up and down and straight left and right changes right now. So imagine that this is your house and this is the store and you're going by blocks, right? You'd have to go up to this corner and over this way. So we'd go up and to the right, or the other thing we could do is we could say, well, I'm starting here at the store and I want to get home. Well, in that case, I would go down and to the left, but it's really the same trip, right? It's the same difference in height and in width, if we want to call this, or horizontal distance between those 2 points. So we want to remember this rise over run And then in this case here, when we look at this, the change in the quantity, meaning in the y values, and then change in the input, which are the x values. Okay. In this case, this is time, the years, and this is how much is consumed of whichever the milk or the soft drink that we're looking at. Okay, so you might remember this also. So we have this formula for slope. We say slope equals y2 minus y1 over x2 minus x1. Okay, so let's just take a look at what this means. First of all, this comes from having 2 points that are on that line. So again, let's think about this point here and this point here. They're both on that line. So this point, I'm just calling one of them x1, y1, and I'm calling the other one x2, y2, just like a label. It's not squared, it's just saying first point, second point. So if I want to find out the rise or the difference in height or vertical space between this first point and the second point, well, I subtract the height where this one is minus the height where this one is. That will give me that difference. There's my y2 minus y1, or again, gives me the rise. If I want to find the horizontal distance between these two, or again, the difference between here and here, then I'm taking the x value over here on this graph and subtracting this x value, x2 minus x1. Okay, so that's how we're going to find the slope, and we'll use that here in just a minute. Okay, in this problem situation, the quantity or y value is gallons and the x value is time in years. The x value is also called our independent variable. You might remember hearing that before, because I can give any value I want for x, and depending on what my value of x is, I get out a certain value of y, which is called my dependent variable. So, oops, not value, I should say variable, sorry. My dependent variable. So if I say, okay, how much milk was consumed in 1956? Well, then I chose that out of any year I wanted, and then there's a y value that depends on that. We would say, I'm just making this up, 27 gallons of milk, or whatever it would be. Okay, so find the slopes or rate of change for both the U.S. consumption of milk per person and the U.S. consumption of soft drinks per person. So there are two different things we have to do here, okay? We first have to find the slope of milk. That's one thing. And then separate question, we're going to find the slope of the soft drink consumption. Okay, so just kind of set this up here. For each one of them, slope, and sometimes we call slope M. I don't honestly know why we use M to stand for that, but if you would like to, you can. So M or slope, either one, equals y2 minus y1 over x2 minus x1. So it's how the y value changed over how the x value changed. Well, let's think about what that means in this case. So we have x's and we have y's, right? And in this case, the y value is gallons, how many gallons, and the x value is time, in this case, sort of years, okay? It is, we'll look at it as years right now. Okay. So I need some information about how many gallons were consumed and what time that was. So let's just look at milk first. We need information about how much was consumed at different times. So if we go back to that spot that I said we'd need to come back to, up here, oops. Okay, here's where we have some information that we need. So let's just look at milk first, okay? So it says here, in 1950, each person in the U.S. consumed an average of 36.4 gallons of milk. So that's one piece of information, right? In 1950, the average was 36.4. In 2000, that number had decreased to 22.6 gallons of milk. Okay, so if we kind of put this out here together, we know that in 1950, the average was 36.4 gallons, and in 2000, the average was 22.6 gallons, and this is for milk. Well, we know that in this particular situation, we're calling our time our X value, and the amount of gallons is our Y value in a certain point. So I can put this together as a point. Remember, a point or an ordered pair is just a pair of quantities that go together, two pieces of information that are related. So these two are related because in 1950, the average consumption was 36.4 gallons of milk. So go ahead, take a second here and write out your other point. Okay. I'm not doing this as an Edpuzzle, so if it takes you a second, you can just pause the video. All right. Think about what it would be and then start it again. So the other point is going to be that in 2000, what went with that was 22.6. Okay. So let's go back down here then with that information. So 1950 is 36.4. I'll write this over here. Let's see, we'll write it in red so we can see it. So 1950 is 36.4, and 2000 was 22.6. Okay, so we take the y's and we subtract. So it doesn't matter which one you start with as long as you're consistent. If I'm going to do the newer value for y, I have to do the newer value minus the older one for x also. So I can say 22.6 minus 36.4. So I subtract the y's. Now notice that our y value is our second number, but it's what goes on top of the slope. So it's kind of opposite of what you might think. So I did the second point minus the first point for y. I have to do the same order for x's. Okay, if I subtract 22.6 minus 36.4, let's see what we get. So I'm going to do that on my calculator, and I'm going to get 22.6 minus 36.4 is negative 13.8. So hang on to the thoughts about that negative for just a minute, okay? And then if I do 2000 minus 1950, I'm going to get 50. Now, it says to round to the 3 decimal places. So we can see that we don't want to leave it as a fraction. We want to round it by dividing to turn that into a decimal. So if I take negative 13.8 and I divide it by 50, I get negative 0.276. So actually, that's the final, that decimal ends right there, so we don't even have to round it. Okay, so let's talk about this for a minute. Why do you think that this was a negative? Okay, think about it. It might seem a little weird to have a negative. Well, let's think about what the slope means. So when we're thinking about slope in a context, we always want to think about the units. So the y value was gallons, right? So this is minus 13.8 gallons. And then this is years or time, right? So time was measured in years. So over 50 years. Minus 13.8 gallons over 50 years. Think about why I might have a negative slope here. What's happening to the milk consumption? Well, my milk consumption went down, right? It went down 13.8 gallons over a course of 50 years. When I divide this, essentially what I'm doing is dividing and then putting it over 1, but it's going to be negative 0.276 gallons per year. So this is how much it goes down on average each year. So if in 1 year, average person in the US is drinking a certain amount of milk, the next year they'll be drinking 0.276 gallons less, about a quarter of a gallon less. So it makes sense that this is negative. The negative means that quantity went down over time. Okay, now let's look at slope of soft drinks. So again, I'm not going to do this as an Edpuzzle, but I'm asking you to put the time in with this and the effort so that you are learning from it too, right? So you're going to stop the video, try some things on your own. Okay, so now let's look at soft drinks. So we'll use greens and blues for soft drinks here. Okay, so the average number of gallons of soft drinks consumed per person in 1950 was 10.8. By 2000, this number had increased to 49.3 gallons of soft drinks per person, right? It's the average. Okay, so let's look at this information. So for soft drinks, we know that in 1950, in 1950, 10.8 gallons per person on average. In 2000, 49.3 gallons per person on average. All kind of other things we can talk about with that, right? Maybe in the healthcare field, but we're just gonna kind of look at the data in here. So again, this is going to be my X values. These are going to be my Y values that go with it. So 1 point is going to be 1950. Oops. Sorry, randomly hit something here. 1950, comma 10.8, and the other is going to be 2000, 49.3. Again, X, Y, time, gallons. So 10.8 and 49.3. So let me write them over here again so we have them. So 10.8 and 49.3. Okay, so let's find the slope, right? We're going to take y2 minus y1 over x2 minus x1. Again, I told you before that it doesn't matter which one you call 0.1 and 0.2. So what happens is, let's look back at the other one for a second. If I had switched these and I said, I'm going to do 36.4 minus 22.6, I'm going to have a different order on top, that's okay. I would have ended up with positive 13.8. But if I did this in the order of 36.4 minus 22.6, I have to do the years in that same order. So I would have 1950 minus 2000, and I'd have this be negative 50. So either a negative divided by a positive, or if I switch them, I'd have a positive divided by a negative. They both become a negative. And likewise, if you have two positives, if you switch both orders, you'll have two negatives, which divides to a positive. So the order doesn't matter as long as you're consistent between the 2 points. So y2 minus y1, I'm going to do new minus old again. So in this case, I'm going to do 49 minus 3. Sorry, 49.3, didn't sound right in my head, minus 10.8. So I will get, I'll put it in here, 49.3 minus 10.8 equals 38.5. Okay, I did second minus first. I have to do second minus first here. Which is going to be positive 50. Okay, again, I divide, and even though it says to round to the nearest to 3 decimal places, which would be the thousandths, this one actually ends in the hundredths, so you can just leave it like that. Again, remember the units. This is gallons, this is years, right? So 0.77 gallons per year. Okay, so if I were in class, I would stop here and have some discussion around why this one is positive. So think about what you would say if we were in class and I asked you, how come this slope is positive? Well, maybe it helps to think about, why was this slope negative? The slope was negative because the amount of milk consumed went down every year. Soft drinks are going up every year. And if you look at this, milk is going down by about 1/4 of a gallon per year. Soft drinks are going up by about 3/4 of a gallon. So they're changing faster. And you can kind of see that from the numbers too, right? There was a much bigger increase here than the decrease there. Okay, so number 2 is just kind of leading you into the next part. So if let time t be 0 in 1950. Okay, so when 1950 is here, then t equals 0. So before we get to this, if I'm calling 1950 t equals 0, think about what I would call 1951. Well, if this is 0 and I'm counting by year, I'm going to call this 1, right? And I'm going to call 1952 2. And I'm going to call 1960, think about what I would call that. Well, if I'm just working my way up, that would be 10 years. So what would t be in 2000? Think about how many years between 1950 and 2000, and t is going to equal 50. This is just kind of rewriting the year. Instead of having just a year that's a 4-digit number of our year, we're just saying, okay, if 1950 is kind of our starting point in this, for whatever reason, that's the data they gave us. Maybe that's the first year that this data was collected, or the first year that soft drinks were really showed up on there. That's going to be our 0 point, 1950. So we're kind of thinking about this time now as the number of years since 1950, right? Okay, so moving on. Let the time t be 0 in 1950 as it is in question 2. Use the slope you found for the U.S. consumption of milk per person to find the quantity of milk consumed in 1985. So this is my t. All right, so let's go back for a minute here. Question 2. Slope for milk. So our slope for milk, we said it's going down 0.276 gallons per year. All right, so how can we find what the quantity of milk is that's consumed in 1985? All right, so I want you to think about this for a second. The starting value for this was 36.4. So when we look at milk in 1950, and in general, on average, people were drinking 36.4 gallons of milk per year in the US. Okay, well, it went down 0.276 gallons every year. Okay, so I'm just going to kind of start you out, and then I want you to really pause the video and think about this on your own. This is one of those things that most of the time our groups in class can work this out on their own, okay? So if my year is here and my number of gallons is here, kind of like my X and my Y, right? If this is 1950 and it's 36.4 gallons, think about what 1951 would be. How does this change? How does the number of gallons change from 1950 to 1951? Well, we know that it has to go down 0.276 gallons. So how would I know what the next year's number is? Well, I would take 36.4 and subtract 0.276. And I would get 36.124. Now, is this what it's asking us? No, but this gives us an idea, right? What if we had one in 1952, 1953, all the way up to 1985? Now, I don't really want to have to write out every year. So think about what happens. Kind of think about what this t would be in this case. T is the number of years since 1950. What number would that be? And also, what happens with this slope? What does that tell us? So I would like you to pause the video for a minute. See if you can figure out what the value of t is in this case. And how much milk is being consumed in 1985. So if you haven't paused the video, really go pause it and try it, okay? You're not going to learn anything just by waiting for me. Okay, so hopefully you paused it, came back. So it's supposed to go down 0.276, 276 thousandths of a gallon every single year. So if I think about this T idea, how many years has it been since 1950? Well, my T is 35. It's 1985 minus 1950. So this is my T. This is how many years I've been doing this. Well, every single year, I go down by the same amount. When it goes down or up over and over and over the same amount, that's where I look at multiplication. So I'm going to say 35 times negative 0.276, and that gives me negative 9.66. So you always want to stop and think about, what does this mean? Like, what am I doing? Don't just try to, I think sometimes students just try to start pulling stuff like, oh, we multiply, we add, we subtract. Well, wait to take a pause, right, and think about what this means. This is how much it goes down in 1 year. This is how much it went down in 35 years. So this is the number of gallons lost, I'm going to say, okay, since 1950. So what can we do now? Well, in 1950, it was 36.4 gallons per year. It went down by 9.66 gallons per year. So I can go ahead and make this a 3, make this a 10. This is going to be 4. I exchange one of those for 10 tenths. 13 minus 6 is 7. 15 minus 9 is 6. So that means that in 1985, the average consumption of milk, was 26.74 gallons. Okay, so what did we do? We said, well, it goes down this much per year, and we want to see how much it is after it's gone down for 35 years. So I started at 36.4, subtract 0.276, subtract it again 35 times, right? That's essentially what I did here. I took 35 groups of negative 0.276. This is the total amount then, and then I can subtract that all at once. Okay, so trying to remember what I'm doing here. Okay, so now we want the time to be 0 in 1950, as in question 2. And use the ideas from lesson 4.1 to build linear models for both U.S. consumption of milk per person and U.S. consumption of soft drinks per person. All right, so I want to talk to you for just a second about, in general, what a linear model looks like, right? We talked about it before. So here's what it is. It's going to be my amount. I'm going to say A for amount equals, okay, change per item or time period times the number of items or time periods plus the starting value, okay? Or that can be minus also. So let's think about this just in words. This is kind of our template for a linear model, okay? A just meaning the amount, whatever we're trying to find. So this makes sense, right? Think about the starting value. Let's say I have, $5 in my piggy bank. And every time I sweep the kitchen, I'm going to get paid $1 by my kids, right? Some wishful thinking. So I have a certain amount of money. And then here's what changes over time. The starting value doesn't change. I start with $5. Nothing's going to change that, the fact that I started with $5. So then if every time I sweep the kitchen, I get $1, then it's going to be $1. It's going to, my amount in my piggy bank is going to go up by $1, so positive change of 1 times, let's say I sweep 8 times, $1 times 8. Or let's say that every month gas prices are going up 3 cents. Okay, this doesn't really happen linearly, when they go up and down, but let's just pretend for a little bit of time. Well, here's the starting value of gas at the beginning of that month, let's say, or the beginning of that year, whatever my time is. And then every month it goes up by 3 cents. So plus 0.03 times however many months it's been. Now we don't know. And again, when we have a formula or an equation, we want it to work in lots of situations. We don't want it only to work when there's been 6 months or 3 months or whatever. So we can use a variable here to show that this quantity can vary, right? That's the word we use to say that it can change. It can vary, variable. So here's the milk consumption. So I want you to build this model. And what I want you to do is have, I'll kind of write the parts above it. So we have the change per time period times the number of time periods plus the starting value. Okay, so again, I want you to really give this a try. Pause the video. Think about what each of these is. Remember that it says, well, I guess it doesn't say exactly in here, but when we think about this one right here, change per time, or another way to talk about that is rate of change. Think about, what did we just call rate of change? What tells us, oh, it went down this many gallons per year or up this many gallons per year? Okay, think about that for a minute. Okay, so for real, go ahead and pause your video and see what you can do about writing both of those linear models. Okay, so let's come back. So we know for milk, so M is going to stand for the consumption of milk, right? What parts is that? Well, my change per time is my slope. Milk went down. It went down 0.276 per year times however many years. Well, let T be 0, right? So I have T here plus my starting value was 36.4. So let's also, this goes with M here, M equals this. Let's also see how this is constructed. If I say it is 1950, then my T would be 0, this would be 0, this whole thing cancels out, and it's just 36.4 gallons per year. But then after, when T is 1 in 1951, I take 36.4 and I add this negative, in other words, subtracting 0.276. Okay, now if you didn't stop it before, or if you did and got it wrong, you didn't get to go on to the second one, go ahead and stop it now and do the same thing for soft drinks. Okay, so for this one, we should have very similar setup. Our change, remember, for the sodas was positive. It was positive, let's see. Let me go back up here, I guess, right? So the soda change was positive 0.77 gallons per year. 77 gallons per year times the number of years plus, I think it was 10.8, yep, oops. Plus 10.8. Again, this is my starting value. This is how many gallons average person was drinking in a year in 1950. And then every time there's another year, that goes up by 0.77 gallons. Okay, so these are our two linear models. Remember, a linear model is an equation that models or shows what's happening. Those are our two linear models. And we could use anything we want to find out the time. We can use any value of t. Now remember that t, oops, that's not what I wanted to do. So just remember that in this case, t is the years since 1950, not the year itself. So if we do that same example of 1985, I don't put 85 or 1985 in here, I put 35 in for t. Whatever I plug in there, the output will be the number of gallons of soft drinks or milk consumed that year. All right, so I'm going to fill in this table using your models. So again, let me just write them over here. M equals negative 0.276 T plus 36.4, and soda is 0.77 T plus 10.8. Okay, so you're going to go ahead and fill in this table using your models. You're just going to plug in. So for example, when 1950 T is 0, so if this is 0, this whole thing goes away. My milk is 36.4 gallons. Same thing happens here with T equals 0. So this is going to equal 10.8 gallons, okay, which makes sense. In 1950, those were our starting values. All right, so in 1960, think about what T is. T is now 10. So for milk, I could say negative 0.276 times 10 plus 36.4. Right, I multiply this, I get negative 2.76 plus 36.4. So now I can figure out what that is, which it is going to be, oops. Okay, 33.64. So this means that, again, you always want to sort of orient yourself back to like, what is this, right? Well, what was I trying to do? I was trying to figure out the number of gallons of milk consumed. So I put in a certain value for how many years it had been since 1950, and this is my answer I get. This is the number of gallons of milk. They were consumed in 1960, right? So I'm going to put this here, 30, oops, not there. This is going to be 10, and this one is going to be 33.64. You'll do the same thing with soft drinks all the way down through, okay? Again, think about what T is going to be in each of these cases. And I will post the filled in table and data, because I want to just have you have some time to finish that. When you plot this data, okay, on the side over here, this is going to be the number of gallons. And this down here is going to be time since 1950. So it's going to start with 0 and go up to whatever it is up here, okay? It's not the year, it's the time since 1950. So when we do this, just remember you're not counting the blocks inside, you're counting the lines, right? The division lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Yeah, I thought that. So I remember it's like 24 boxes there. We can, now technically this goes up to 1950, so it's going to be 50 on the x-axis. We can just kind of go up to 48 and not have to have that last point in, that's fine. Again, you'll have to see what you're going to count by this way and label that also. So what you're going to be plotting, there's two different sets of numbers you're going to get out of this table. So T is like my X, that's going to be the same for each. So for milk, I'm saying here, after 0 years, 36.4 gallons were consumed. After 10 years, 33.64 gallons were consumed, etc. For soft drinks, I'm going to use that same T, 0, but 10.8 is my soft drink, right? So when it had been 0 years from 1950, how much milk, how much soft drinks? When it had been 10 years since 1950, how much milk, how many soft drinks? Okay, so you're just going to fill those in and do that. Once you do that, this is, when you look at these numbers that you have here, these are all pairs that can be graphed. So 0, 36.4. Now you'll have to figure out what you want to count by here, right? By 2s or 3s or whatever, and then you're not going to have it exact. There's no way you're going to have exactly 36.4 graphed, right? But you want to figure out where's 36, where's 37. It's just below halfway between those two. So do a good job trying. Now you're going to have two different graphs on this same grid. So one is going to be the milk. Think about what happened to the milk as time went on. So I'm thinking about my axes. As time went on, the amount of milk people drank went lower. So that is similar to the latte. What's happening to the soft drinks? Well, as time goes on with the soft drinks, the amount of consumption goes up. Okay, so you're going to see two different lines there. They're both going to be graphed on that same plane. And then can use the table and the graphs to approximate when the consumption of milk per person equaled or will equal the consumption of soft drinks per person. And then referring to the graph, what's the significance when time is 0? What do these points form on the graph or represent? And use the equation models to find when the consumption of milk and soda was or will be equal. Okay, so what I'm going to do is I'm going to stop this video and ask you to finish this chart, draw your graph, and then see what you can do with 7, 8, and 9. Okay, I will post a second video that has the answers to all of this.